You're welcome once again to our Maths and Physics class, where we teach Maths and Physics in depth for your understanding. We are still continuing with dimension of physical quantities. Today we are going to be dealing with area, and we will also bring in volume. Then, if you recall, you are going to see that we have been using MLT. M is for mass, L is for length, YT is for time. Remember, they have their SI units. The SI units for mass is kilogram, the SI unit for length is meters, and the SI unit for time is seconds. We established that in our previous videos. So we're also going to bring that into this. I told you, always remember, before you start to dimension anything or any physical quantity, the first thing you have to do is to write the formula. So what is the formula for area? What is the formula for area? We're going to pick a particular example using rectangle. Rectangle is length times what? Breadth. Now let us look at this rectangle or the rectangular plane figure. If I measure from here to here, I'm measuring length. We call it length, isn't it? Okay. If we also measure from here to here, we call it breadth. The question now is, if I measure from here to here, is that not the same thing as length? I'm also measuring length. But to differentiate between the longer side and the shorter side of a rectangle, we call it length and breadth. But actually, are we not measuring length and length in the two places? Yes. So it means that breadth is also known as what? Length. Breadth is also length. So it is L, just from what we have there on the board. Okay, if we have this as LL, so how do we now dimension? So we'll now say area. Area is equal to what? Length times breadth. Area is equal to length times breadth. So I can represent this breadth from there. The explanation we have had to be what? Length times length. So breadth is actually length. But we use L and B to differentiate the longer and the shorter, as I have said before. But actually, we are measuring length. Whether you measure from here to here is length. If you measure from here to here is length. So we can actually represent it with LL. Recall our laws of indices. We said the product law, that when two variables or two numbers are the same, what do? You pick one and add their powers. Look at it. This length is L raised to power 1. This is also L raised to power 1 because this 1L, 1L. L raised to power 1, L raised to power 1. From the law of indices, we said pick one and add their powers. L raised to power 1 plus 1. So it's now mean L raised to power 2. L raised to power 2. So area, the dimension of area is L raised to the power of 2. Okay, now, how can I get the SI unit of area from this dimensioning? What is the unit of length? What is the unit of length? The unit of length is what? Meters. It is meter raised to power 2. That is why when you calculate area, at the end you say meter square. So if I calculate the area of a rectangle, if for instance I have 36, will I just leave it as 36? No, you must add the SI unit. That is why you see meter square. Or at times, if the dimensioning or the measurement is given in centimeters, you have centimeter square. If it is given in kilometers, you have kilometer square. So it is always square, and this is where it is gotten from. We just explained that using rectangle as case study, length and breadth are actually length of different values. When we have length and length, we have length raised to power 1, length raised to power 1. From law of indices, pick one. This is a product law in the law of indices. Pick one, then add their powers or add their indices together, and you have L raised to power 2. If we look at the length, we have the SI unit of length being meters. And if that one is true, then it's going to be meter square. And that is why you have meter square as the SI unit of what? Of area. Thank you. So let us look at the other one that has to do with volume. So what is the dimensioning of volume? The first thing, like I said, and I'll be repeating, write the words, the formula. Volume is equal to what? Length times breadth times height. We're still going to use a case study of a cuboid. Look at this cuboid that I'm drawing. Where is the length here? Look at it. Where is the breadth? Look at it. Where is the height? Look at it. Just like I explained for rectangle. If we measure from here to here, are we not measuring length? Yes, that is length. If I also measure from here to here, which is the height, am I not also measuring the length from here to here? Yes. So I can also call this one another length. What is this breadth? If I measure from here to here, I'm also measuring another length, which is another length. It's just that the lengths are different. If, for example, we are talking about cube, cube has the same length, whether it's the height, the breadth, or the length, as we may call it, or call them. They have the same in cube, but for cuboid, it is not like that. That's why we differentiate them to be length, breadth, and what? And height. All of them are actually lengths. So, if we have that to be so, then it means that I can represent this L times another L times another L. So these ones are length, breadth, height. They are all lengths. So volume, this is the dimensioning of volume. This is L raised to power 1, L raised to power 1, another L raised to power 1. So that will give us L raised to power what? 1 plus 1 plus 1. Because this is now law of indices, product law, that if you have the same number or the same variables multiplying themselves, add their powers together, just pick one of the variables. We pick 1 now to be L, we add the power of this to this to this, and we're having 1 plus 1 plus 1. And that will give us L raised to power 3. That is why you have volume equal to this dimensioning. So how do we relate this one to the SI units of volume? What is the SI unit of length? The SI unit of length is meter. And we have raised to power 3 here, we put that raised to power 3. So when you calculate volume and you are having, for instance, 20, what do you write next? You say meter cube. Volume is equal to 20 meter cube or 20 cm cube. So this cube, the length cube, is gotten from the dimensioning of volume. You see, while I said that the essence of dimensions of physical quantity is for you to be able to know the content or the constituent of such a physical quantity, and as well to be able to generate its SI unit if you do not know or if it is confusing. So that is where we are going to end the class for today. We are saying that you should continue to follow us, continue to subscribe to our channel on YouTube, continue to like and continue to comment on this video. Do not please forget to share these videos for others to benefit, and as well to encourage us to do more of these videos and drop them. And when we do, you are going to be among those that will get these videos first when we upload them. Thank you.